Okay, so we're starting 5.5. Okay, so let's look at this one. We should all be familiar with this question by now. So, explain why measure of angle 1 is greater than measure angle 3. Okay, so the first thing we want to do is answer this question, which I know I already answered it. It's because I wanted all the parts to be shown, but it's fine. So, which statement can be made according to the corollary to the triangle exterior angle theorem? What is the triangle exterior angle theorem? That's the theorem that tells us that the measure of angle 1, in this case, is equal to the measure of angle 2 plus the measure of angle 4. So what the triangle exterior angle theorem really is, or the is the exterior angle is equal to the sum of the two non-adjacent interior angles of that triangle. So this angle is equal to the two non-adjacent. This is the adjacent one, so we don't want that one. That one we don't care about. The sum of these two. Okay? So, knowing that, do you guys think if it takes this 4 and this measure angle 4 and this measure of angle 2 being added together to equal 1, do you think there's ever a situation where 4 is going to be greater than 1? Or where 2 is ever going to be greater than 1? If it takes 2 of these guys being added together just to equal this one measure of angle 1, then there's no way individually they can ever equal to it, let alone be bigger, correct? So now, using that logic, let's look at this. Which statement below can be made? So, measure of angle 1 is greater than measure of angle 4. That's true. Measure of angle 1 is greater than measure of angle 2. That's true. Let's look at the other ones, though. So, measure of angle 1 is greater than 4 plus 2? No, we just said it's equal. You can't just change your mind. We know this to be true, so this is false. Now, measure of angle 1 is less than 4 and 2? No, that's also not true. So the measure of angle 1 is less than measure of angle 4. We just talked about that. How can 1 be less than 4 if 4 needed 2 just to equal it? So that's wrong too. That's wrong as well. So now, let's look at the next thing. Since measure angle 2 and 3 are what? What are measure angle 2 and 3? Well, if we were to pull out this parallel line and extend this parallel line as well, parallel, and what would be my transversal line? This one. What would I know about 3 and 2? They're what? They're alternate interior angles. Okay? So alternate interior angles. And what do I know about alternate interior angles on a transversal that is transversing two parallel lines? If they're parallel lines, then they are congruent. So that's why we have 2 is equal to 3. Now, I have these right here. So I have this known to me. And now I have this known to me. So how can I make this leap right here? Well, I can use substitution, right? So that now I can do, okay, well, I want something that looks like this. I want something that looks just like this. So what kind of looks a little bit almost like this? Well, this one does a little bit because it has the 3 there, right? But it doesn't have the 1. So this has a 1 and this has a 1. Okay, so this has a 2 and a 3. So you see how we're like starting to build, we're working backwards in a way. So if 1 is greater than 3, okay, and 2 is equal to 3, okay, so that means, so if 2 is equal to 3, then maybe I can make this, like maybe I had a measure of angle 1 is greater than measure of angle 2, and then I can just substitute this 3 onto there. So let's see, is there something like that? Right here. So if I start at this, measure of angle 1 is greater than measure of angle 2, and then I know that 2 and 3 are alternate interiors, therefore 2 and 3 is the same exact measurement, then can I just substitute this 2 for this 3 to then give me this answer? I can, and I did, and that's why the answer is correct. So I hope that everybody can follow this. We've done it a few times in class. Now, everybody should be getting these type of questions right. I already said this a myriad of times, right? That an angle and its opposite side are directly proportional. That means the bigger my angle, the longer the length of the opposite side, and the smaller my angle, the shorter the length of the opposite side. So here, I want to look at my longest side, and that'll tell me my biggest angle. So what is my longest side? This one. What's my second longest side? This one. What's my third longest side? This one. So that means this is my greatest angle. This is my second greatest angle. And this is my third greatest angle. So from smallest to largest, what is my smallest angle? B. And then A. And then my least smallest, or my largest, whatever, my largest is C. So where is that? BAC. BAC. Okay. So here as well. So list the angles of the triangle in order from smallest to largest. Okay, well, they want me to find angles, but I don't have angles. They gave me lengths. So let's draw a triangle with those lengths. Does it matter how I draw my triangle? Does it matter if it's equilateral, if it looks like an equilateral, if it looks like a right? No, it doesn't matter at all. I'm just putting an arbitrary random triangle. So AC is 6, BC is 9, and BA is 4. So that means what would be my biggest angle? A would be my biggest angle. Why? Because it's opposite to the longest side length. This 9 right here. What's my second biggest angle? B. What's my third biggest angle? Or my smallest? C. So from smallest to largest, I'm going to start at the smallest, which is C, then B, then A. So where's CBA? Right here. Okay. Let's look over here. List the sides of the triangle in order from shortest to largest. Okay, so I need the sides, but I don't have the sides. All I have is the angles. So let's finish this angle. What is... okay, 89. I'm too lazy to get my phone right now. So 3, 1, 12, 133, 47. So this should be 47. I hope I did that right. Yeah, okay. So if this is 47, what is the largest angle? N. So what's the longest side? This one. What's the second largest angle? The O. So what's the second longest side? This side. What's the third longest side? This one. So from smallest, the shortest side length is what? ON. Then it's MN. And then the longest is OM. So on NO, wrong, NO, MN, OM, right here, A. Okay. Once again, list the sides of each triangle in order from shortest to longest. Okay, so I don't have any side lengths. All I have is angles. So I'm going to draw my triangle. A, B, C. My B is 1, 110. I'm not even going to draw the angle. Oh no, actually, yeah, because I'll confuse you guys. A is 29, and C is 41. So what is my largest side length? This one, AC. What's my second largest? So what's my shortest to longest? My shortest is my BC. Then it's AB. And then it's AC. So where does it say that? No, 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 no. Right here. F. Okay. Now, this is important. Can a triangle have sides with the given lengths? Remember, the two sides of a triangle, any two sides of the triangle must be greater than the third side. So A plus B must be greater than C. B plus C must be greater than A. obviously this A, B, and C's are all side lengths. So all the side lengths must be any two side lengths must be greater than the third side. So the answer is no, because 4 plus 8 is what? 12. So 12 is not greater than 13. So it's wrong. So the answer is no, no. But why is it no? Because of this. Because of the fact that 4 plus 8 is greater because of the fact that 13 is greater than 12, that contradicts the triangle inequality theorem, which is this. That any two sides of the triangle must be greater than the third side. Okay? Now, this is important. This is the third side rule. A triangle has sides of 3 and 3. What can be concluded about the length of the third? So remember, the third side must be greater than. If you guys are able to finish my sentences, then that's really good. That means that you're doing great. Greater than the difference and less than the sum. So I'm gonna write a range, and whenever I do my range, I'm gonna put like that. So what is the smallest that my angle can be? Well, it has to be greater than the difference. So what is 3 minus 3? 3 minus 3? 0. And less than the sum. Okay, so what is less than the sum? What is 3 plus 3? 6. So my angle has to be between 0 and 6, not including 0 and 6. Remember, the reason we say not including is because we don't have this equality, this little half an equal sign there. It's not less than or greater than. Less than or equal to, it's just less than. Okay, so x is greater than 0 and x is less than 6. So what will be my answer? C. The side is longer than 0 and shorter than 6. Okay, so for the longest side of triangle ABC, okay, cool. So I have a triangle A, B, C. They want me to find my longest side, but all they gave me is angles. So let's plug that in. So A is 35. B is 3x minus 10. And C is 4x plus 15. So I don't have any angles. I only have this exact angle, but I don't have anything else. So I need to find my x. I need to find my x so I could plug it back in and then actually figure out what's the angle A, what's angle B, and what's the measures of these angles. So what I'm going to do is I'm going to equate all of these up to what? 180. Because what do I know about all sides of a triangle? They equal to 180. So I'm going to have 35 plus 3x minus 10 plus 4x plus 15 equals 180. I'm going to combine like terms here before I go to the other side, before I start flipping things around the equal sign. So what is 35 minus 10? That's 25. What's 25 plus 15? That's 40, right? Yeah, 40. And now, what is 3x plus 4x plus 7x equals 180? Now I'm going to subtract 40. So 7x equals 140. And I think that's 20 because, yeah. So x is 20. So this x is 20 doesn't give me my answer, but it helps me to find my answer. So now I'm going to plug this in. I'm going to plug in this 20 onto the 3x minus 10. So what's 3 times 20? 60. What's 60 minus 10? It's 50. So this angle's 50. What is 4 times 20? That's 80. I already know it's bigger. It doesn't even matter what the answer is because 4 times 20 is 80. So 95. So is this valid? 30. Yep, this all equals up to 180. So what is the longest side length? The longest side length is the one opposite to the largest angle. I know C is the largest angle. So my AB is the longest side length. Okay? Now, determine which segment is the shortest. Okay, so let's find the rest of my angles. Okay, I'm going to go get my phone for this. Okay, so let's find the missing angles. So let's find angle Y. So this is 47. So that's 47, and the other ones would be 70 and 70. How do I know it's already 70? Because I know that there's 70 because this is an isosceles triangle, right? And what do I know about base angles? What do I know about the base angles of an isosceles triangle? Or in other words, the sides opposite to the legs, they're congruent. So it's just 180 minus 40 divided by 2. And that'll give me this. So this one is tricky because the shortest angle here is 40. So one would think that XZ is going to be the smallest side. However, remember what I told you guys, that triangles, their angles have a direct proportion. And what a proportion is, it's not an exact number. So that means even though this angle right here has a measure of 40 opposite to it in this triangle, it has a measure of 47 in this triangle. So yes, this side right here, this side opposite to this angle is the smallest side in this triangle. But in this triangle, the smallest side is actually this one. And this perceived smallest one over here, this XZ, actually has a 47 degree to it. So what's the actual smallest side? It's actually going to be ZX. We've talked about it in class a lot of times because it's hard, you know, so I hope that you guys were paying attention because this is one of the hard ones. So even though this is 40, this XZ is 40, is proportional to the 40 degrees, that's only speaking in this triangle. I want to speak about both triangles. Why? Because this XZ shares a side with this triangle and with that one because of the reflexive property of congruence. So yes, in this case, for this triangle, it's 40. For this triangle, it's 47. And when I compare 47 to this 43, which one's smaller? This one's going to be a little bit smaller. So if this one's a little bit smaller than this one, even though this has a 40, it doesn't mean anything. This is still going to be smaller because if this is smaller, in general, it'll be smaller. This side length is not going to change. So if I've already proven that in this triangle, this ZY is a little bit smaller than this ZX, then I don't really care what angle goes on here when I've already proven that this ZY regardless is smaller than this XZ. So my answer is actually ZY. So I hope everybody was paying attention because like in that lesson and going over this question because it's difficult, okay? I'm going to be honest with you, it is pretty difficult. So let's do this one. Very similar, so let's take out your calculator. So 180 minus 119 minus 33. So this is 28. This right here is 28. And let's find the other one. 180 minus 114 minus 41. 25. Okay. So once again, let's see. Okay, so the smallest side in this triangle is this NL, and the smallest side in this triangle is LK. So do you guys already know why the answer is actually LK? Because you guys should already know, like based on the previous problem, that if this is 25 in this triangle, well, this NL shares a side, so it's not that easy. Yeah, maybe it's 25% of this guy. Or not 25%, but 25 degrees proportional to this guy, but it's 33 in this triangle. So in this triangle, this NLK, what is smaller? This NL or this LK? Well, it's the LK because it's opposite to the 28 degrees. So if this is a little bit smaller than this one, then that's it. It's done. It's end of discussion because this LK is a little bit smaller than this one, period. I don't care what this degree is anymore. Understand? So LK would be the answer here. Okay. Identify the two statements that contradict each other. So what a contradiction is like, okay, I won't be accepting any late work on Monday. And then people ask me on Monday if they can turn it in, and I say yes. I contradicted myself. No, I said one thing, but then I said something else that wasn't in line with the other thing that I said. So let's take a look at this. Each of the two items that Val bought, each of the two items that Val bought cost more than $12. Okay, so they each cost more than $12. So they cost $12.01. Okay, Val spent over $28 for the two items. Well, if each of the two items cost more than 12, what is 12.01 plus 12.01? That's 24. Okay, so that doesn't really help me here, because they cost more than 12. So yes, so you might be thinking, mister, there's a contradiction right there. She spent okay, let's just say it's 13, just to make our life easier. Okay, mister, she spent 13 and 13, so that's 26. Val spent over $28, so that's a contradiction. 1 and 2 are contradicting each other because she spent $26. It said Val bought cost more, that she bought two things that cost more than 12. What if they were 20? What if she bought two things that were $20? What's 20 plus 20? 40. So now, is there a contradiction here between these two? No, there's not. Remember when we talked about statements? If it's wrong, statements, keyword, if it's wrong once, it's wrong forever. Okay, it's wrong for perpetuity. So, what about this one? What about 1 and 3? Each of the two items that Val bought costs more than $12, and neither of the two items that Val costs more than 14. Well, that's true. Look, if each of the two items that Val bought cost more than 13, she could have spent 13. That's fine. She could have spent 13. So now neither of the two items that Val bought cost more than 14. Okay, that's fine. What if they cost 13? They're not, you can have something in between 12 and 14, so that's fine. There's no contradiction within there. Now the other combination is 2 and 3. So let's see. Neither of the two items that Val bought cost more than $14. So the maximum that she could have spent if neither of the two items cost more than $14 was, what's 14 times 2? Or 14 plus 14? 28. So the most Val could have spent, according to this statement 3, was $28. So now let's read statement 2. Val spent over $28 for the two items. So that means she had to at least spend $28.01. That's how, in statement 3, if the most she could have spent was 28, how is she now spending $28.01? It's impossible. That's your contradiction. So you click this drop down menu and you put 2 and 3. Okay? Now, last question. And remember, we talked about indirect proof. What is an indirect proof? An indirect proof is a way of proving something wrong by proving that the opposite of the statement we're trying to prove true is actually is true. So like, okay, so an indirect proof is getting that statement that we're trying to prove true and finding the opposite of it, and then trying to prove that that's also true. And what's going to happen is that there's going to be a contradiction that occurs. And then if there is a contradiction that occurs, then you know that your original statement was right the whole time. Okay? So let's look at this. So I want to prove that A is obtuse. Okay, so I want to prove that A is obtuse. So what is the opposite of A is obtuse? It should be A is not obtuse. Okay, so if I wanted to use indirect proof to prove this correct, to prove this truth actually valid, then I would need to say, that A is not obtuse. But what does it say here? Assume temporarily that A is a Q. What? That's not how we go about doing indirect proofs. That's That's not how we do it. So what should it be? The negation, or the opposite, remember the opposite? The negation of A is obtuse should be is not obtuse. So let's look at not obtuse right here. Is D. The negation of A is obtuse is A is not obtuse. So this is the correct answer.